All right, so in this video, we're going to talk about the acidity and basicity of salt solutions. All right, so oftentimes, when we're thinking about acid-base neutralization reactions, we'll think, okay, well, if we add an acid and a base, it's going to be the resulting products are going to be neutral. And to tell you the truth, that's not always typically really the case. All right, or like the salt is a neutral salt. And so let's kind of talk about what do we mean by this. All right, so like if you have HCl plus NaOH, so here's your acid, here's your base, okay? And then so what we're going to form is you want to form a salt plus water, all right? So here's our salt here. All right, so here's our salt. All right, so sodium chloride is our salt. It's the ionic compound. All right. Now, when we consider the salt and what makes up the salt, one thing that you need to realize is that the salt consists of components that comes from both the acid and the base. It's usually always the same case in every single acid-base solution, right? And so, like for example, the anion always comes from the acid. So the chlorine part's coming from the acid, and then the cation always comes from the base. All right, so that's always the case. So this is the basic portion of the salt, and this comes, and right here comes is the acidic portion of the salt that comes from the acid. All right, so these are the two components that your salt always made up of. All right, now if we're talking about the acidity or the basicity of the salt solution, it really just kind of depends. It really kind of depends on what type of acid and what type of base it's mixed together in a neutralization reaction. And it helps us to determine if that salt solution is either acid or base. All right, so let's kind of go through just different combinations and see what type of solution it will form. So remember, the cation comes from the base, and the anion of the salt comes from the acid. All right, and so let's say if the cation was from a weak base, okay, and the anion came from a strong acid. So we're talking about the salt here, okay? And so in this case, this solution will be acidic, all right? And so let's look at some examples. And so some examples of this would be like NH4Cl, all right? Cl, this chloride will most likely would have come from a strong acid like hydrochloric acid, all right? And NH4 would have came from a weak base like ammonia, NH3. All right. Another example is NH4NO3. The NO3, your anion would have came from HNO3. All right. A nitric acid, which would be a strong acid. NH4 once again would have came from a weak base as NH3. All right. So these two are salts. All right, and these salts will most likely will make a solution acidic. Now, how does this happen? All right, so let's consider, right? You would have the NH4 plus, which is that's the salt, right? Remember these are all aqueous solutions. So aqueous, they will all dissolve. All right, so you will have this as in solution, just ammonium ion. All right. Now, if it's in solution, it's going to be in contact with water. Okay. Now, because this is a weak base, all right, or this is the conjugate acid, really, of this base here, what's going to happen, because this is going to be the conjugate acid, all right, and this is going to act like a base, all right. And what I mean the conjugate acid, it's the conjugate acid of the ammonium, right? Because remember, we said that the base was NH3, all right? So if that's your base, then NH4 plus is going to be your conjugate acid. All right, so ultimately, this is going to act like an acid. H2O is going to act like a base. So the the ammonium ion is going to lose the hydrogen to the water. All right. And so then it's going to form NH3 again. All right. Plus H3O plus. All right. Now, why is the solution acidic? Is because the NH4 plus creates this H3O hydronium, and we know that anytime you have hydronium or hydrogen ions in a solution, then you have, or if you have more hydronium ion solution than you have hydroxide ions, then we have ourselves an acidic solution. So it's because the NH4, all right, of the salt that's dissolving there induces more hydroniums to be produced, then we have ourselves an acidic solution. Now, what if the cation of the salt was from a strong base, and the anion of the salt came from a weak acid? Well, if that's the case, the solution is going to be basic. All right. And so, what are some examples of this? We have NaHCO3. All right. So, sodium bicarbonate, potassium acetate. Here's just two examples of this. All right, of these type of salts. Now, what's going on? All right. So, well, actually, let's kind of break these salts down so that we could kind of see exactly where we're getting this from. So remember, the cation is coming from a strong base, right? And typically, a strong base consists of a metal and a hydroxide, right? A metal hydroxide. So here we have sodium, we have potassium. So these are our metals. So kind of give us an idea that we're dealing with a strong base when we have these metal ions, these metal cations, okay? And then from the anions, what we see here, these anions are essentially conjugate bases of weak acids, all right? So your acids are weak here. Hydrogen carbonate is a conjugate base of the weak acid, carbonic acid. And then acetate is the conjugate base of the weak acid, acetic acid. All right, so these are just the conjugate base versions of these. All right, so that's the way that you could kind of tell that we're dealing with a salt that consists of a strong base and a weak acid. All right, and once again, as I said, when you have this salt in the solution, then know that your solution is going to be basic. All right, now how is that so? So let's look at this example here. So if we have the hydrogen carbonate or bicarbonate, right, which in this case we're going to use this as an example. So here's your bicarbonate, all right, and if it's in water, okay, the bicarbonate is going to act like a base, right? Because when you think about it, it's going to be the conjugate base, because since originally, right, so we have, get something to write with. All right, so remember, it's your weak acid. So like carbonic acid is your weak acid, right? This is your acid. So its conjugate base, this is the conjugate base. All right, so this right here is going to act like a base. All right, while in this case, water would then act like an acid. So water is going to lose the hydrogen to the bicarbonate ion. All right, and when this happens, you will have H2CO3. So you have carbonic acid again. All right, aqueous. Plus now you have this hydroxide. Now, what causes that this solution, this salt, the presence of this salt causes that the solution to be basic, is that you increased the concentration of hydroxide within the solution. Remember, this is your base component, all right? And so because you increase the concentration of hydroxide in the solution, then ultimately this is the reason why this is the reason why the solution is now basic. So what if the salt is made from a a cation. Um, it's made from a strong base. The cation's coming from a strong base, and the anion, the salt, comes from a strong acid. All right. Then the solution here will actually be neutral. Okay. And so, what's are some examples? NaCl, potassium bromide, calcium nitrate. Okay. To where we see here's we got the metal. All right. So the metal here. So this tells us when we see these metals that we know that they're coming from metal hydroxide. So this lets us know that this came from a strong base. And then you have these anions that when you attach an H to it, then we know these are your strong bases, strong acids. All right. And so then we have these salts here. And anytime you see these salts, then you know for sure that it is a neutral compound. All right. Anything, because these are coming from strong acids, makes very weak conjugate bases. Very, very weak conjugate bases do not really relatively react with water all that well. All right. So if you have a conjugate base, it will not react with water really, really well. So it won't really make an acidic. It won't turn the water to hydroniums. And same thing with strong bases. Strong bases have very weak conjugate acids. All right. And so due to that, it's not going to change the water to hydroniums. All right. And so that way you're not going to really have you're not going to change the pH of the water all that well. All right, so that's the case. Then we can look at a couple example problems. So for example, if we have like BaCl2, here's a salt. All right, now we have to see, okay, will this salt produce a basic, acidic, or neutral solution? Well, let's consider what it's made up of. Remember, this right here, the cation always comes from your base. All right, so that's your basic portion. And your anion always comes from your acid. All right, now we just have to see, okay, is it from a strong acid or strong base, or a weak acid or a weak base? Well, for the base, we have this metal here. All right. So most likely this metal came from, it most likely was a barium hydroxide. Now barium hydroxide will be a strong base. All right. So we know this is a strong here. And then this chloride, all right, if you attach an H to this chloride, because this right here is literally just a conjugate base, but then we pass the H back to it, we see that HCl is a strong acid. All right, so both of these are strong. A strong with a strong will make it a neutral solution. What about the salt sodium cyanide? Okay, remember, this is your base. This is your acid. Okay. Now this base here, we have a metal. So most likely this is a metal hydroxide. So that's strong. All right. Your acid here, CN. So it was HCN. Now cyanic acid is a weak acid. So we have a strong base with the weak acid. So this tells me that this solution will be a basic solution, because whatever is stronger, that's what's going to be. Okay. All right. What about the substance ammonium nitrate? Okay. And so the ammonium, your cation comes from your base. Your anion nitrate comes from your acid. All right. So in this case, because it's NH4, if it loses a hydrogen, it becomes the base again, which is NH3. So that's your base. We know this is a weak base. NO3 comes from the acid HNO3. So this is a strong acid. So if that's the case, then we know we have ourselves an acidic salt solution. All right, so that's how you're able to tell, looking at what type of salts, if it's an acid, base, or neutral.